limit of x tends to 0 tan x minus sin x upon x cube equals a 1 by 2, b minus 1 by 2, c 2 by 3, or d none of these. What we do first is we write tan x in terms of sin and cos x. That gives us limit of x tends to 0 sin x by cos x minus sin x upon x cube. Now we multiply cos on with sin x and x cube. That gives us limit of x tends to 0 sin x minus sin x cos x by x cube cos x. So then we take sin common, we get limit of x tends to 0 sin x 1 minus cos x upon x cube cos x. We can write 1 minus cos x as 2 sin square x by 2. Therefore, we get limit of x tends to 0 into sin x 2 sin square x by 2 upon x cube cos x. Now we'll have to write this x also in terms of x by 2 so that we could solve it easily. So we could write limit of x tends to 0 sin x by x into 2 by cos x and sin square x by 2 upon x by 2 the whole square into 1 by 4. Now applying limit to each of these terms individually, we get 1 by 2, which is option A. Limit of x tends to 1 minus root x upon cos inverse of x the whole square equals a1, b1 by 2, c1 by 4, or d none of these. So first what we have to do is write cos inverse of x as y. So let me write that down. Cos inverse of x equals y. And if x tends to 1, we'll have y tends to 0. So now we can continue with the sum. We could write limit of x tends to minus 1 x tends to 1 1 minus root x upon cos inverse of x the whole square equals limit of y tends to 0 1 minus root of cos y upon y square. Now rationalizing it, we get limit of x y tends to 0 1 minus cos y upon y square into 1 plus root of cos y. Now we could solve this in a easier way. Y tends to 0 1 minus cos y by y square into limit of y tends to 0 1 upon 1 plus root cos y. Now we apply the limit to each of these terms individually. That gives us 1 by 2 into 1 by 2, which is equal to 1 by 4. That is option C. Limit of x tends to pi by 4 root 2 cos x minus 1 upon cot x minus 1 equals a 1 by root 2, b 1 by 2, c 1 by 2 root 2, and d 1. So first what we do is we write it in terms of sec. So we'll have limit of x tends to pi by 4 into root 2 minus sec x cos x into 1 plus cot x. Now we have the numerator in terms of sec and cos. So we'll have to do the same with the denominator. So cot x minus 1 would become cot square x minus 1. Next, what we do is we take limit of x tends to pi by 4 root 2 minus sec x into cos x into cot x plus 1 into tan square x upon 2 minus sec square x. That would give us limit of x tends to pi by 4 cos x 1 plus cot x into tan square x. After terms have been cancelled out in the numerator and divider. So we have root 2 plus sec x in the denominator. Then we apply the limits of x tends to pi by 4 on the numerator. That gives us 1 by root 2 into 1 plus 1 into 1 square, and the denominator as root 2 plus root 2. Solving these two, we would get 1 by 2, which is option B. Limit of h tends to 0, 2 into root 3 sine pi by x plus h minus cos pi by 6 plus h equals upon this equation upon root 3 of h into root 3 cos h minus sin h equals a minus 2 by 3, b minus 3 by 4, c minus 2 root 3, or d 4 by 3. So first we would write the numerator as limit of h tends to 0, 2 into root 3 sine pi by 6 plus h minus cos pi by 6 plus h. Upon root 3 h into root 3 cos h minus sin h. Now that gives us limit of h tends to 0, 4 by root 3 by 2 sine pi by 6 plus h minus 1 by 2 cos of pi by 6 plus h upon h root 3 cos h minus sin h, which equals limit of h tends to 0, 4 by root 3 sin h by h into 1 by root 3 cos h minus sin h. Now applying the limit h tends to 0, we get the answer 4 by 3, which is option D. Limit of x tends to 0, x by tan inverse of 2x equals a 0, b 1 by 2, c 1, or d infinity. What we could do is multiply and divide by 2. That gives us limit of x tends to 0 into x by tan inverse of 2x into 2 by 2. So now applying the limit of x tends to 0 on this term, we would get this as 1, and which leaves us with 1 by 2. So 1 into 1 by 2 equals 1 by 2, which is option B. Limit of x tends to pi by 2 cot x minus cos x upon pi minus 2x the whole cube equals A 1 by 16, B 1 by 8, C 1 by 4 or D pi by 2. So first we have limit of x tends to pi by 2 into cot x minus cos x upon pi minus 2x the whole cube. That can be written as limit of x tends to pi by 2 into, take cot x common, we have 1 minus sin x upon pi minus 2x the whole cube. Now this could be written as limit of x tends to pi by 2 tan of pi by 2 minus x into 2 sine square pi by 4 minus x by 2 upon 2 into pi by 2 minus x into 16 pi by 4 minus x by 2 the whole square. So this could be written as 2 by 32 limit of x tends to pi by 2 tan of pi by 2 minus x upon pi by 2 minus x into limit of x tends to pi by 2 sine of pi by 4 minus x by 2 upon pi by 4 minus x by 2 the whole square. Now applying the limits of x tends to pi by 2 to both these terms individually, we would get 2 by 32 since they both are equal to 1. The 2 by 32 is nothing but 1 by 16, which is option A. Limit of x tends to 0, e raised to x square minus cos x upon x square equals A 3 by 2, B minus 1 by 2, C 1 or D none of these. Now to solve this, first we apply L'Hopital's rule on this equation. So that gives us limit of x tends to 0, e raised to x square would be 2e raised to x square plus this becomes sin x upon 2x plus limit of x tends to 0 to sin square x by 2 upon 4x square into 4. Now applying the limit of x tends to 0 on both these terms individually, we are left with 1 plus 1 by 2, which is 2 plus 1 by 2, which is 3 by 2, which is option A. Limit of theta tends to 0, 4 theta into tan theta minus sin theta upon 1 minus cos 2 theta the whole square is A 1 by root 2, B 1 by 2, C 1 or D 2. Therefore, we write this as limit of theta tends to 0, 4 theta tan theta minus sin theta upon 1 minus cos 2 theta the whole square. That gives us limit of theta tends to 0, 4 theta sin theta into 1 minus cos theta upon 4 sin raised to 4 theta cos theta. Now in solving this, we could write it as limit of theta tends to 0 to sin square theta by 2 upon 2 sin theta by 2 into cos theta. Now we get this on solving this equation to give us, we could write it as limit of theta tends to 0, theta by sin theta into 2 sin square theta by 2, upon sine square theta cos theta. This makes it easier to solve this equation that gives us this result. Now we could solve this further as limit of theta tends to 0, 1 by 2 into 1 by cos square theta by 2 into cos theta. Applying the limit of theta tends to 0, we are left with the constant 1 by 2, which is option B. The value of limit x tends to 0 log of 1 plus r cube by sine cube x equals a0, b1, c3 or d, none of these. So for this we use L'Hopital's rule on this. That gives us limit of x tends to 0 into 3x square by 1 plus x cube upon 3 into sine square x into cos x. Now solving that further, we get limit of x tends to 0, 1 by 1 plus x cube x by sine x the whole square into 1 by cos x. Applying the limit of x tends to 0 on this term, we are left with 1 by 1 plus 0 into 1 square into 1 by 1. That is nothing but 1, which is option B. Limit of e raised to tan x minus e raised to x upon tan x minus x equals a1, be, ce raised to minus 1 or d 0. So we could write this as limit of x tends to 0, e raised to x, e raised to tan x minus 1 upon tan x minus x. That on solving gives us limit of x tends to 0, e raised to x, limit of x tends to 0, e raised to tan x minus 1 upon tan x minus x. Applying the limit of x tends to 0 on this equation, we are left with e raised to 0 into 1, which is nothing but e raised to 0, which is 1, option A. If f of x is equal to 2 by x minus 3, g of x is equal x minus 3 by x plus 4, and h of x is equal to minus 2 into 2x plus 1 upon x square plus x minus 12, then limit of x tends to 3, f of x plus g of x plus h of x is a minus 2, b minus 1, c minus 2 by 7 or d 0. We know we have to solve for f of x plus g of x plus h of x. Therefore, we could add all these three terms, that is f of x plus g of x plus h of x, giving us x square minus 4x plus 17 minus 4x minus 2 upon x square plus x minus 12. That is nothing but x square minus 8x plus 15 upon x square plus x minus 12. To solve these two equations, we are left with x minus 3 into x minus 5 upon x minus 3 into x plus 4. X minus 3 cancel out, we are left with x minus 5 upon x plus 4. Therefore, we can now apply the limits. Limit of x tends to 3 into x minus 5 upon x plus 4. That is minus 2 by 7, which is option C. The value of limit x tends to 0, a raised to x plus b raised to x plus c raised to x by 3 the whole raised to 2 by x, where a, b, c are all greater than 0 is a, abc the whole cube, b, abc, c, abc raised to 1 by 3 or d, none of these. So what we do first is, we could write it as we could say y is equal to limit of x tends to 0 into this term, that is a raised to x plus b raised to x plus c raised to x by 3 whole raised to 2 by x. So therefore we could apply log on both the sides, giving us log y is equal to limit of x tends to 0 2 by x log of ax plus bx plus c raised to x by 3. Now we could write this as 2 limit of x tends to 0 log of a raised to x plus b raised to x plus c raised to x by 3 minus log 3 when this goes on top and leaves us with x in the denominator. Now we apply L'Hopital's rule on this term, which leaves us with log y on the left hand side and log of a, b, c raised to 2 by 3 on the right hand side. Now if we remove the log on both the sides, we are left with y is equal to abc raised to 2 by 3. Therefore the answer is D, none of these. The value of limit x tends to 2 root of 1 plus root 2 plus x upon x minus 2 minus root 3 is A 8 by root 3, B 1 by 4 root 3, C 0 or D none of these. Now we have this term, it could be written as limit of x tends to 2 1 plus root of 2 plus x minus 3 in the numerator and root of 1 plus root of 2 plus x plus root 3 into x minus 2. That gives us limit of x tends to 2 root of 2 plus x minus 2 upon root of 1 plus root of 2 plus x plus root 3 into x minus 2. Now we could solve this and write as limit of x tends to 2 x minus 2 upon root of 1 plus root of 2 plus x plus root 3 into x minus 2 into root of 2 plus x plus 2. Now applying limits on this whole term, we get 1 by 2 root 3 into 4. That is 1 by 8 root 3. It's option A. Limit of x tends to 0 sine of x plus sine of a minus x minus 2 sine a upon x sine x equals a sine a, b cos a, c minus sine a or d 1 by 2 cos a. So this could be written as limit of x tends to 0 2 sine a into cos x minus 1 upon x sine x. We get this by expanding the terms sine x plus a and sine a minus x. Next we write limit of x tends to 0 minus 2 sine a into 1 minus cos x upon x square into x by sine x. We further solve this, giving us limit of x tends to 0 minus 2 sine a into 2 sine square x by 2 upon 4 into x by 2 the whole square into sine x by x. which is nothing but minus sine a on applying the limit of x tends to 0, which is option C. The value of limit x tends to 1 sine of e raised to x minus 1 minus 1 upon log x is a0, be, c 1 by e, or d 1. So therefore we could write this as limit of h tends to 0 sine of e raised to h minus 1 upon log of 1 plus h. We get this by putting 1 minus x minus 1 as h. Next we write limit of h tends to 0 sine of e raised to h minus 1 upon e raised to h minus 1 into e raised to h minus 1 by h into h upon log of 1 plus h. This gives us limit of h tends to 0 sine of e raised to h minus 1 upon e raised to h minus 1 into limit of e raised to h minus 1, this should be here, upon h into limit of h tends to 0 h by log of 1 plus h. Applying the limits into all of these terms individually, we get the answer 1, which is option D. Limit of x tends to 0 x e raised to x minus log 1 plus x by x square equals a 2 by 3, b 1 by 3, c 1 by 2, or d 3 by 2. Now we take this term and apply L'Hopital's rule to get 0 by 0 form. It gives us, we could write it as y equals limit of x tends to 0 e raised to x plus x into e raised to x minus 1 by 1 plus x upon 2x, which is now in 0 by 0 form. Therefore we have y is equal to limit of x tends to 0 1 by 2 into e raised to x plus e raised to x plus x into e raised to x plus 1 by 1 plus x the whole square, which is y equals limit of x tends to 0 1 by 2 into 1 plus 1 plus 0 plus 1. Now applying the limit of x tends to 0 on this, we are left with nothing but 3 by 2, which is option D. Let the function f be defined by the equation f of x equals 3x if x is greater than 0 but less than 1, and f 5 minus 3x if x is greater than 1 but less than equal to 2. Then limit of x tends to 1 f of x is equal to f of 1. B. Limit of x tends to 1 f of x is equal to 3. Limit of x tends to 1 f of x is equal to 2, or limit of x tends to 1 f of x does not exist. So we'll have to solve it using the method. We take the left hand side of f of x as limit of x tends to 1 minus f of x equals limit of h tends to 0 f of 1 minus h, which is equal to limit of h tends to 0 3 into 1 minus h, which is nothing but limit of h tends to 0 into 3 minus 3 into 0, which is equal to 3. Then we solve for the right hand side, or RHL. We get limit of x tends to 1 positive f of x limit of h tends to 0 f into 1 plus h, which is equal to limit of h tends to 0 5 minus 3 of 1 plus h. On solving this, we get limit of h tends to 0 2 minus 3h. Applying the limits, we get 2 minus 3 into 0, which is equal to 2. Therefore, we could say, hence, the limit of f of x, where x tends to 1, does not exist, which is option D. Limit of x tends to 4, x raised to 3 by 2 minus 8 upon x minus 4 equals A 3 by 2, B 3, C 2 by 3 or D 1 by 3. This sum looks a little bit tricky, but it's easier when we apply the L'Hopital's rule. On applying the L'Hopital's rule to this term, we get limit of x tends to 4, 3 by 2, x raised to 1 by 2 by 1 equals limit of x tends to 0. Now this could be solved, and applying the limit x tends to 4, replacing x as 4, we get 3 by 2 into 4 raised to 1 by 2, which is nothing but 2. Therefore 3 by 2 into 2, we get 3, which is option B. Limit of x tends to 0 sin inverse of x minus tan inverse of x by x cube is equal A 0, B 1, C minus 1 or D 1 by 2. Seeing this equation, we can say it is in 0 by 0 form. Therefore, we apply L'Hopital's rule and we could write it as limit of x tends to 0. Sin inverse of x becomes 1 by root of 1 minus x square minus tan inverse of x becomes 1 by 1 plus x square and x cube becomes 3x square. Now this too is in 0 by 0 form, and therefore we could write it as limit of x tends to 0 into minus 1 by 2 into minus 2x by 1 minus x square raised to 3 by 2 plus 2x by 1 plus x square the whole square. We write this or adjust the terms so that the limit can be applied individually and we could solve it easier. Therefore, we get limit of x tends to 0, 1 by 6 into 1 by 1 minus x square raised to 3 by 2 plus 2x by 1 plus x square the whole square. On applying the limits x tends to 0, we are left with 1 by 2, which is option D. Limit of x tends to 0, a raised to x minus b raised to x upon e raised to x minus 1 equals a log a by b, b log b by a, c log ab or d log a plus b. Therefore, we could write this as limit of x tends to 0, a raised to x minus b raised to x upon x into x by e raised to x minus 1. We get this by multiplying and dividing by the term x. Now this equals limit of x tends to 0, a raised to x minus 1 upon x into minus b raised to x minus 1 by x. This into x by e raised to x minus 1, which is nothing but log of a to the base e minus log of b to the base e into 1 by log of e to the base e, which is nothing but log of a by b to the base e, which is option A. if f of x equals cot inverse of 3x minus x cube upon 1 minus 3x square, g of x is equal to cos inverse of 1 minus x square upon 1 plus x square, then limit of x tends to a, f of x minus f of a upon g of x minus g of a, where a is greater than 0 but less than 1 by 2 is a 3 by 2 1 plus a square, b 3 by 2 into 1 plus x square, c 3 by 2, or d minus 3 by 2. So first what we do is we could write f of x is equal to cot inverse of 3x minus x cube by 1 minus 3x square, and we could write g of x as cos inverse of 1 minus x square upon 1 plus x square. Now in both these equations we put x as tan theta. Therefore we get f of theta equals cot inverse of 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, which is nothing but cot inverse of tan 3 theta. Then we write f of theta equals cot inverse of cot of pi by 2 minus 3 theta, which is nothing but pi by 2 minus 3 theta. Therefore we get f dash of theta equals minus 3. We could write this as 1. Now for g of theta, we have g of theta equals cos inverse of 1 plus tan square theta upon, this is minus 1 minus upon 1 plus tan square theta. This is nothing but cos inverse of cos 2 theta, which is cos inverse and cos get cancelled, leaving us with 2 theta. Therefore g dash of theta equals to theta. Now we can apply the limit of f of x tends to a or x. So we have applying the limit of x tends to a, f of x minus f of a upon g of x minus g of a. We would get limit of x tends to a, f of x minus f of a upon x minus a into 1 by limit of x tends to a into g of x minus g of a upon x minus a, which is nothing but f dash of x into 1 by g dash of x, which is minus 3 by 2, which is option D. Limit of x tends to 0, e raised to x minus e raised to minus x sin x is a 0, b 1, c 2, or d non-existent. What we could do is to solve this easily, we apply L'Hopital's rule. That gives us limit of x tends to 0 into e raised to x minus e raised to minus x by sin x. Now applying the rule, we get limit of x tends to 0 e raised to x plus e raised to minus x upon cos x, which is equals, on applying the limit of x tends to 0, we get e raised to 0 plus 1 by e raised to 0 upon cos of 0. All these terms equal 1, so therefore we get 1 plus 1 by 1, which is equal to 2, which is option C. Limit of n tends to infinity, 3 raised to n plus 4 raised to n raised to 1 by n equals a3, b4, c infinity, or d e. we could solve this by writing limit of n tends to infinity 4 raised to n raised to 1 by n in the bracket 3 raised to n by 4 raised to n plus 1 raised to 1 by n. Now this equals limit of n tends to infinity 4 into 1 plus 1 by 4 by 3 raised to n, this whole raised to 1 by n. Now this gives us limit of n tends to infinity with the constant 4 outside 1 plus 1 by 4 by 3 raised to n whole raised to 1 by n. Now we apply the limit of n tends to infinity and replace n by infinity. That gives us 4 into this term cancels out and we are left with 1 raised to 0, which is nothing but 1. Therefore we get 4, which is option B. Limit of f integral of 0 to x into 1 by root of 1 plus t square minus 1 by 1 plus t dt as x tends to infinity is a log e to the base 2, log of 2 to the base e, log of 1 by e to the base 2, or log of 2 to the base 1 by e. So we could write this as applying the integral into each term individually, we get limit of x tends to infinity integral of 0 to x 1 by 1 plus t square the whole root dt minus integral of 0 to x 1 upon 1 plus t dt, which is limit of x tends to infinity into log x plus root of 1 plus x square into minus of log 1 plus x. This gives us limit of x tends to infinity into log x 1 plus root of 1 by x square plus 1 upon x into 1 plus 1 by x. On applying the limit x tends to infinity into this term, we are left with log 2 to the base e, which is option B. Limit of x tends to 0 sin x minus tan x upon cos x minus sec x equals a1, b0, c infinity or d, none of these. First we write this term in terms of sin and cos only, giving us limit of x tends to 0 sin x minus sin x by cos x upon cos x minus 1 by cos x. That gives us limit of x tends to 0 sin x cos x minus sin x upon cos square x minus 1, which equals limit of x tends to 0 sin x cos x minus 1 upon minus sin square x. Solving this, we get limit of x tends to 0 1 minus cos x upon sin x. On applying the limit x tends to 0, we are left with 0, which is option B. Limit of x tends to 2 x raised to 100 minus 2 raised to 100 upon x raised to 77 minus 2 raised to 77 is equal to a 100 by 77, b 100 by 77 into 2 raised to 22, c 100 by 77 into 2 raised to 21, d 100 by 7 into 2 raised to 23, or e 100 by 77 into 2 raised to 24. So we could write this as we need to first write x in the term as 2 plus x. So therefore x tends to 2 when h tends to 0. Now it is easier to solve when we'll have h tends to 0, 2 plus h raised to 100 minus 2 raised to 100 upon 2 plus h raised to 77 minus 2 raised to 77. Now we have limits of h tends to 0, 100 into 2 raised to 99h plus all the multiples of h square upon we'll have 77 into 2 raised to 76 into h into all the multiples of h square. Applying the limit of h tends to 0, here we will have only the terms which don't depend on h coming out as constants, leaving 100 by 7 into 2 raised to 23, which is option D. Limit of x tends to 0, x by root of 1 plus x minus root of 1 minus x is a 0, b 1, c 2, d minus 1 or e minus 2. So therefore we could write it as limit of x tends to 0, x by root of 1 plus x minus root of 1 minus x, and we multiply and divide by the denominator's conjugate. That gives us root of 1 plus x plus root of 1 minus x upon root of 1 plus x plus root of 1 minus x. Now it is easier to solve, and that gives us limit of x tends to 0, x into root of 1 plus x plus 1 minus x upon 1 plus x minus 1 minus x, which is equal to limit of x tends to 0, x by 2x root of 1 plus x plus root of 1 minus x. Now applying the limit of x tends to 0 in these terms, we are left with 1, which is option B. Limit of x tends to infinity, x cube by 3x square minus 4 minus x square by 3x plus 2 is equal to a minus 1 by 4, b minus 1 by 2, c 0, d 2 by 9, e minus 6 by 5. So first we could solve this part, which gives us a limit of x tends to infinity, 3x raised to 4 plus 2x cube minus 3x raised to 4 plus 4x square upon 3x square minus 4 into 3x plus 2. Now we could write and solve this numerator, giving us limit of x tends to infinity, 2x square into x plus 2 upon 3x square minus 4 upon 3x plus 2. Now this gives us limit of x tends to infinity, 2 into 1 plus 2 by x taking 2 common upon 3 minus 4 by x square into 3 plus 2 by x. Applying the limit of x tends to infinity on these terms, we are left with 2 in the numerator and 3 into 3 giving us 9, 2 by 9, which is option D. The value of limit x tends to 0 sine square x plus cos x minus 1 x square is a 1, b 1 by 2, c minus 1 by 2 or d 0. So therefore we could write it as, we could solve this and write it as limit of x tends to 0 cos x minus cos x cos square x upon x square. Now we have limit of x tends to 0 and this would be 1 minus cos x upon x square, and take cos x out. Now that equals limit of x tends to 0 to sine square x by 2 by using the formula upon x by 2 the whole square into 4. So therefore, on applying the limit x tends to 0, we get 1 by 2, which is the constant left out, which is the option B. If limit of x tends to infinity into x square plus x plus 1 by x plus 1 minus ax minus b equals 4, then a is equal to 1 and b is equal to 4, b a is equal to 1 and b is equal to minus 4, c a is equal to 2 and b is equal to minus 3, or d a is equal to 2 and b is equal to minus 3. So therefore we could write limit of x tends to infinity x square plus x plus 1 upon x plus 1 minus ax minus b is equal to 4 as given in the question. Then we write limit of x tends to infinity, and expanding terms we have x square 1 minus a plus x 1 minus a minus b plus 1 minus b upon x plus 1 equals to 4. Now the limit is finite and it exists when 1 minus a equals 0. So from this we can say a is equal to 1. Then we can say limit of x tends to infinity 1 minus a minus b plus 1 minus b by x upon 1 plus 1 by x equals 4. We know a is equal to 1, so it has to be either of these two options. So now we have to solve for b. If 1 minus a minus b equals 4, which we get on applying the limit x tends to infinity on this term, and since we have found out the value for a is equal to 1, we have minus b equals 4. Therefore we could say b is equal to minus 4, which is option B.